In my game, you can move the camera by WASD and zoom it in and out through a scroll wheel. Though I have a camera system that will follow the player's movements, in this game, it's not really necessary as the player will move through a mouse click, and for me, it's just inefficient for a gameplay. Now, to code this, we need to create a script and name it Camera Zoom and Movement for Organization. As we can see, I have already made a script. Under the video, there will be a code for you to copy and paste or modify it as you please. Now I'm going to explain how this works. Under the public class mono behavior contains a public float data which you can edit it in the inspector. If I'm going to explain this, CS scripts usually used to add features to the Unity game engine, especially if you want a specific implementation for your game. In my case, I want to add a movement to the camera through WASD and zoom in and out through a scroll wheel. Now let's go back to the explanation of the script. Together with the public floats, there will be also a private. This code allows us to get the component feature of the Unity, which is the camera. By the name, it will not appear or editable in the inspector, but it will work in the background as you start the game. While the serialized field private float allows us to edit the variables, but also not directly accessible to other scripts if ever we want to reference this code. Now let's start to the main loop. Void start, by the name itself, will start working when the game is start. This is a very useful function to load and get the components as you can see here, which is needed for the void update to work with. Now, the void update. This will be the main game loop. How this works is every frame of the game will check for conditions or functions that you put in the code. As you can see, we have a cam movement and a cam zoom functions, which I made to create the movement of the camera. Now, let's try to understand the logic behind the functions. As you can see, there are if statements containing the conditions that the code needed to implement the logic. You see this? This is movement. If using the move tool in the inspector, you can see the camera's coordinates changes in the X and Y axis, while the Z don't change, so we don't really have a problem with that. All we have to do is to get the key input WASD in the conditions and create a logic where we can add or minus the axis values according to the direction of the camera we want to move. If you don't understand, let me put this in a statement. If the S key is typed, the X value stays the same, while the Y value is minus by 0.1f and minus by the camera movement speed, which is 1f. The camera movement speed variable determines how fast the camera moves, just like the name suggests. With that logic, we can do it to other conditions. Now for the camera zoom functions. So as you can see, in this code, we already defined the scroll. We have to define scroll is equals to the input axis of the mouse scroll wheel. So this means every time that I will scroll my mouse wheel, this code will call. And with that, we have already defined, so we can just only say scroll because it's just literally the same. So now since we have already called the camera, or we have already inputted or get the component camera, this is the camera, we can just use the camera itself. And what component of the camera we're going to use? So we can use the projection of the orthographic camera, which is the size. So as you can see, it can change, right? So we can use that. So what we're going to do is to edit this size from our code here. Float new size is equals to the cam, which is we're gonna call again the component camera, and that orthographic size, which is the specific thing that we want to edit, and every scroll is multiply it by the scroll speed as a zoom speed, which is the variable that we're going to edit from the inspector itself. As in this case, it will be 5. So the scroll will be multiplied by 5, which is the zoom speed, and we're gonna call the camera orthographic size again to equals to the math clamp function, and we're going to have the 3 variables that we're going to need, which is the new size, which is this one, which is new size is equals to cam orthographic size minus the scroll, then multiply it by the zoom speed, which the values here will be the zoom size. So the zoom size, the value here will become the new size. So the value here, the new size, which will determine which another one, there will be another variable here for the minimum zoom and the maximum zoom, which will be determined by the public float here, which is in this case minimum zoom is equals to 2 and the maximum zoom is equals to 10, meaning if ever the new size will exceeds to the minimum or maximum zoom, it will prevent it from exceeding or decreasing more to the maximum and the minimum zoom.